Module Overview. Land acquisition is not complete without scientific, legal, and spatial validation of the physical land in question. This module introduces you to the technical backbone of land definition and evaluation, land surveying, boundary demarcation, and geospatial analysis. Before any development, investment, or ownership transfer, precise measurement, location accuracy, and land boundary integrity are paramount. Errors in boundary identification, encroachments, overlaps, or poorly surveyed land are among the most common sources of land disputes and legal battles in both urban and rural regions. In this module, you will be introduced to the instruments, standards, procedures, and techniques used by professional surveyors and spatial analysts to determine land dimensions, confirm legal boundaries, and integrate land parcels into national geospatial registries. 1. Introduction to land surveying. Definition and purpose of land surveying in acquisition, history of land surveying and evolution of techniques. Surveying as the scientific measurement and recording of land features, boundaries, and topography categories of land surveys, cadastral, topographical, engineering, control, hydrographic, and boundary surveys. 2. The role of the licensed surveyor. Legal authority and certification of surveyors. Responsibilities in boundary establishment, measurement, and beacon placement, preparing a registered survey plan and the legal implications, understanding survey plan details, beacon numbers, boundary coordinates, X and Y, total land area north arrow orientation, names of landowners and surveyor's seal. 3. Boundary demarcation and legal accuracy. Importance of boundary accuracy in preventing land conflicts, process of physical demarcation using beacons, pillars, or pegs. Types of boundary markers: metal, concrete, PVC, using survey coordinates to plot and verify land shape implications of boundary encroachment or overlap. 4. Survey control systems and national grid references. Use of primary and secondary control points, geodetic control systems, and Nigerian National Survey Grid, NNG, integrating surveys with state and national mapping databases. Survey validation and registration with the Surveyor General's Office. 5. Geographic Information Systems, GIS. Overview of GIS, spatial data management and analysis, use of GIS in land evaluation, mapping, title verification, and development planning GIS applications. Overlapping claim detection, spatial risk assessment, zoning and master plan integration, layers of GIS data, elevation, infrastructure, zoning, hydrology, land use. 6. Global positioning systems, GPS, and remote sensing. Introduction to GPS for field mapping and data collection. Use of RTK GPS, handheld devices, and mobile GPS apps. Advantages over traditional methods: precision, speed, and digital integration. Remote sensing applications, drone mapping, satellite imagery, and photogrammetry. Creating 3D topographic models, elevation profiles, and heat maps. 7. Drone surveying and aerial mapping. Introduction to unmanned aerial vehicles, UAVs, in surveying benefits. High-resolution imagery, time efficiency, and large area coverage. Legal considerations for drone usage in Nigeria, and internationally data acquisition techniques, orthomosaics, point clouds, and DEMS. 8. Cadastral mapping and digital land records. What is cadastral mapping? Definition, purpose, and scope. Relationship between cadastral maps, land registries, and ownership documents. The role of digital cadasters in secure land acquisition and transparency. National cadastral integration and spatial planning. 9. Practical field surveying and map production. Field reconnaissance and base station setup, traversing, leveling, and data logging, survey computation and plotting using AutoCAD, Civil 3D ArcGIS/QGIS, Land Survey Desktop producing. Actionable site maps for developers and government submissions. Learning outcomes. By the end of this module, you will be able to understand the role of land surveying in the acquisition process, read and interpret professional survey plans, identify boundaries using coordinates, GPS, and cadastral maps, use GIS tools for spatial analysis and planning alignment, understand drone and remote sensing technologies in modern surveying, verify accuracy of land shape, area, and position using geospatial tools,